Hello everyone. Today we will solve this numerical problem. This problem was asked in Texas Instruments written paper. Okay. So they have given in the given circuit VCC is connected to 4 volt. V in and V in Z are complementary square wave signals with a high voltage of 4 volt and a low volt level of 0 volt. A voltage step from 0 volt to 4 volt is applied at V in with the corresponding step from 4 volt to 0 volt applied at V in Z. Okay. At time instant equal to 0. They are asking what is the time instant when the voltage at V out reaches 3.5 volt if I equal to 1 milliampere, C equal to 1 picofarad and R equal to 2 kilo ohm. So this is circuit diagram for this question. Okay. So after reading this question, let's solve this problem. So they are saying at t equal to 0, they are applying a square volt, okay, square wave at this terminal from 0 to 4 volt at t equal to 0. And at the same time they are going from 4 volt to 0 volt. They are going from 4 volt to 0 volt means before t less than 0 there is a input available here, okay, and circuit is at the steady state. Then only they are, after that they are applying 0 to 4 volt here and they are going down from 4 volt to 0 volt. Okay, so for t less than 0 circuit is reached to the steady state. Capacitor will be fully charged. Okay, so it will be open circuit since the input is for t less than 0 0. So this transistor is off. The whole current is flowing through the this transistor only. Okay, the whole current is steer to the this transistor. So and capacitor is open. So what will be the node voltage here? It will simply VCC minus I into R equivalent. Okay, so for t less than 0, V in 0, V in Z 4 volt. So capacitor voltage will be 4 minus R equivalent into I. It will come to 3 volt. Okay. Now at t greater than 0, they are applying 4 volt here and they are going 4 volt to 0 volt here. Okay. Now what will happen? And after reaching steady state, the whole current will steer to the this. Okay. Now the current exchange to the this transistor. There will be no current flowing through this transistor. Okay. So when there will be no current flowing through this transistor, whole current flowing through this transistor. After in this condition, suppose the circuit after some time reach to the steady state, then what will be the capacitor voltage? There will be no current here. Okay, resistance drop is 0. This node is pull up to the supply voltage. Okay, so what will be in this voltage? Simply 4 volt. In this supply voltage 4 volt. So at a steady state for t greater than 0, what will be final voltage? 4 volt. So we know that for a first order circuit, we can write a capacitor voltage as Vf final voltage plus initial minus final into e to the power minus t by tau. Final voltage, we know the whole current will steer to the left transistor. Then Vc will be 4 volt. Okay. Initial it have 3 volt. Okay, this case, and final is 4 volt. Now suppose at t equal to t1, they are asking 3.5 voltage. Okay, they are asking in question at what is the time instant when voltage V out is reached to the 3.5 volt. Okay, so now put the value. So 3.5 voltage equal to 4 minus e to the power t equal to t1. Okay, divided by tau. So after solving this, it will come e to the power minus t by tau equal to 0.5. Take both side log. Okay, ln. So it will be minus t by tau equal to ln 0.5. And then what will be t minus tau ln 0.5. 0.5 is nothing but 1 by 2. Okay, so when 1 by 2 will send to the upper, then it will be 2 to the power minus 1 and minus 1 minus cancel. So it will come R equivalent into C into ln 2. What will be the R equivalent? It's R parallel R only. So it will be 2 by 2, 1 kilo, and this is 1. So it will come 1 ln 2. So there was a mistake in unit, but option, this one option is correct, 1 ln 2. So the learning was in this question is we must check the voltage of capacitors for t less than 0. Whenever you see any energy storing element, so must check their initial conditions. Okay, so this problem was based on slew rate. So I hope you can relate the slew rate concept to this question. Okay, so please let me know if you feel any doubt in this question or you see anything wrong in this question. Okay, thank you.